Okay, so we've got to show the region R which satisfies each of these four inequalities. The first thing to notice is that they're all greater than or equal to signs. So it's going to be four solid lines that we draw. If it had have been just greater than or less than without the little equal to bit, then it would have been a dashed line. So the first one is x is greater than or equal to 2. So we go along the x-axis until we find 2, and then we draw a vertical line down through 2, and anywhere along this line the x-coordinate is always going to be 2. But it's x is greater than or equal to 2, so we've got to decide which side of this line makes that true. X is always greater than 2 on this side of the line, and behind it here x is going to take on values less than 2. So we shade out the bit of the graph that we don't actually want. Now for y is greater than or equal to 1. So we go up the y-axis until we get to 1, and then we draw a horizontal line across through 1 on the y-axis, where every point on that line will have a y-coordinate of 1. It's y is greater than or equal to 1 that we're interested in, so we don't want anywhere where y is less than 1 on the graph, so we shade that out. The next line that we need to draw is x plus y is greater than or equal to 6. So we could think about what would happen if we were drawing the line x plus y equals 6. And we would know if x was 0 and we cover up x, then we know that y has to equal 6. So if x is 0, y has to equal 6, so we could mark the point 0, 6 on our grid. If y was 0, so if it's 0 and I cover up, then we can see that x would have to equal 6. So when x equals 6, then y is 0, and we can draw a line through those 2 points that we've just plotted. Now we need to decide whether we're interested in everything above this line or below this line. So we need to test a point, and we can test a point either side of the line. If I choose this point here, where x is coordinate 3 and y has the coordinate 2, well, if x is 3 and y is 2, 3 plus 2 is 5, and 5 is not greater than or equal to 6. So I know everywhere on this side of the line is part of the region which I don't want, so we can shade it out. And then we need to draw this final line here. So we can think about what would happen if we were trying to draw the line 2y equals 8 minus x. Again, we can think, well, what happens when x and y are 0? Well, if x is 0, and I can cover up because it's 0, then 2y equals 8. So if 2y equals 8, then y is going to be 4. So when x is 0, y has the coordinate 4, so I can mark that on the graph. Equally then, if y was 0, then 2 times nothing is nothing. So we would have 0 equals 8 minus x. If we add on x to the other side and bring it across, it's minus there, so it becomes positive on this side. Then we know that x would equal 8 whenever y is 0. So if y is 0, we can go along to 8, and we have another point on that line. So we can join those two up, and then we have the fourth line. But we need to decide, do we need to shade this side of the line or this side of the line? So again, you can pick a point and test it. So if we pick this point here, where it's got x coordinate 4 and y coordinate 3, well, if y is 3, then we would have 2 times 3 equals 8 minus 4. So 2 3s are 6, and 8 minus 4 is 4. But the inequality said 2y has got to be greater than 8 minus x, and 6 is greater than 4. So the point we chose with an x coordinate 4 and a y coordinate 3 is actually part of the graph that we do want. So we want to shade below the line, so it's just this little bit here that's left that's not shaded. We are interested in marking a region R which satisfies all four inequalities. So this part of the graph here that isn't shaded is the region R, and that's the first part of the question complete.